Hello everyone, welcome back. We are now going to be looking at the second problem, F3-8, which states the following. Determine the tension developed in cables AB, AC, and AD. Now, as we looked at the last problem, we noticed that it was a 2D problem, but now we're actually going to be dealing with a three-dimensional problem. And it's not as difficult when you start to get the hang of it, but it is a very long process, so we're just going to go through it. The first step is you will need a free body diagram. This is for most of these kind of problems. It's essential. And so, as I've drawn here, we have our force in AD, force of AC, AB, and even the 900 newtons that's acting in a negative z direction. Once you figure out how to draw the free body diagram and visualize what is really going on, you can then move on to the second step, which is finding all of your components. One of the easiest ones you can really do when we look at the picture is just FAB, because it's only in the X direction. It doesn't have a Y or a Z component at all, so you basically have the vector already. Now we can move on to FAD and then FAC. So we'll start with FAD first, since it's given the triangle like this. Now, one of the things to be careful about is to know what these are really associated with. Like, for example, the 4, this is not Y at all. This is associated with the Z axis. It still is the same process. You just have to be very careful as to which axis you're really talking about here. And so we can then say that 4/5 is equal to FAD in the z direction over your FAD, which is the hypotenuse. And as we've saw from the last problem, we know how to find the z value for it. And we could say the same thing for 3/5, which this would equal what FAD is in the y direction over your FAD, and that gives you your y component for that. We can then move on to FAC, which this one's a little bit more difficult to visualize, but the best way that I can really explain it is this line right here is associated with the x axis. And so it kind of looks like a parallelogram in a sense. And you just try to match what the lines look like with one another, because obviously we know that the 4 one right here is associated with the y. And since the triangle that it gives you in the problem is curved like that, we know that, oh, this kind of looks like what it is in the x direction. And so we could then say that 3/5 here is your FAC in the x direction over your FAC, and that gives you your x component. And we could then say as well that 4/5 is associated with FAC in the y direction, and it gives you your y component. So once you find all of these different components, you can then create your vectors as shown right here. And once you have all your vectors that you need, you can then go into the next step, which is summing up all your forces in the x, y, and the z direction. Now, there is really no great way to start this off except knowing, okay, which one has the less unknowns. And so the more you look at it and the more you fill each of these parts out, you'll notice that the forces in the z direction have less unknowns to deal with, because you only have to deal with 4/5 AD minus 900, because again, the 900 is acting in a negative z direction. Once you start solving for that, it's simple algebra. You multiply 900 by 5/4. That should give you 1,125 newtons. But since that is a really big value, it was better to just say that it is 1.125 kilonewtons. But now we need it in 3 significant figures, so then you will change it to 1.13 kilonewtons. So that's the answer for one of your forces, which actually helps out a ton, because this can actually be plugged into here to find your FAC. And so we now know that 4/5 AC is a part of this formula since it is going in the positive y direction, but your negative 3/5 AD up here is going to be negative. And so you can plug in your FAD value here, not 1.13, but you will plug in what it is up here above because of rounding error purposes. And it's basically the same process that you just did before over here. You will multiply 675 by 5/4, and you should get 843.75. And when you round it to 3 sig figs, it will be FAC is equal to 844 newtons. The same process applies. You can plug in the values that you got here into this Fx equation to find what your FAB is going to be. So it's just going to be FAB because it's on this line, but then it's going to be negative 3/5 FAC because it's actually moving in a negative x direction because your x is over here and it's over and this is over here. So it's moving away from it. So you will then plug in your FAC value, which is going to be this one right here. You plug it in, and you should get a value of 506.25, and rounding this to 3 sig figs, it's just going to be 506 newtons. So these problems can seem very long at first, but once you start drawing free body diagrams and getting up all of your components and turning them into the vectors, and then setting up each x, y, and z component sections, it seems to come together fairly quickly. But it all just depends on how many you do, and over time you'll start to get faster and faster when solving these problems. And so that is the end of the second problem. If y'all have questions, just let me know.